In this video clip, I'm going to finish the configuration of local AS or migration autonomous system 30 to autonomous system 100. So the story so far was that R3 was running autonomous system 30. It was acquired by the company that runs autonomous system 100. And obviously we had to reconfigure the router 3 BGP configuration so that it matches 100. However, we want to give enough time for the customers. Maybe there's hundreds of customers. I only have two peerings. One is switch 1, one is R1. We need to give them time to do their own reconfiguration and reconfigure their boxes to match router 100. Also, we have not enough resources to do this in one go maybe or something. So for the time being, we are presenting ourselves, R3 is presenting itself to those customers as a local AS30. And that actually creates two things that might need addressing. One of them I already did, but let's do a recap of that. So when I have this configuration, let's take a look. So this is my configuration of R3. Now it runs the autonomous system 100, but I present to two of my neighbors, which is here the switch 1. I present myself as I am running local AS30, so it matches their configuration so far. They don't have to do any change at this point. All we had to do is it was a little downtime when we pasted in that configuration. And the same applies for neighbor R1 here. So this is in autonomous system 500, but we present ourselves as if we are running autonomous system 30, not 100. This created actually two problems, and one of them I already addressed, but let's do it again just to see the whole picture now. So when I do that configuration, and now the situation is that autonomous system 500 knows R3 as autonomous system 30 still. When we advertise, let's say R5 is advertising a subnet 10.1.4.0/24, advertises that to R1, and this goes to obviously Internet 1, it advertises that to R2, goes to Internet 2, goes back to Internet 1. And there's a third advertisement which comes from R5, goes to R1, goes to R3, and goes to our Internet 1 as well. And that one is interesting. So obviously for the purpose of this video, I made R3 next hop self for Internet 1 because this is an eBGP connection versus iBGP. And what is happening now on Internet 1, that particular advertisement shows AS500 and something else. Let's take a look at that again. Let's do show IP BGP. And what I see here, for example, 10.1.4. So we've got this from three different sources. And what's interesting here is that when we receive that from R3, it presents or prepends autonomous 30, because for that particular neighbor it presents itself as autonomous 30. So it's added itself by default while advertising that prefix towards Internet 1 as autonomous system 30. So we have this 500, comes from 500 originated, but it has to cross 30. This is not longer the case because this is in reality actually autonomous system 100. So obviously fix for that is to do for those two neighbors. So let's maybe just copy those two neighbors real quick. Neighbor here, what we can do, so that's my R1, we can do no prepend command. That resets the relationship here with R1 and it advertises itself. So now when R5 is advertising that prefix 10.1.4.0 to R1 and goes to R3 and goes to Internet 1, let's see what the result is now. Let's repeat our command show IP BGP, and we see that this particular neighbor now is not advertising, not prepending the AS30, which in reality doesn't exist. So that's one thing, but there's one more thing we need to address. Let's go back to R1 for just a second and do show IP BGP command. Show IP BGP command. So R1 is facing R3, thinking it's AS30. And when we look at the router 1 table, what is advertised by R3, which are those prefixes here, 133.133, what we observe is that in the path we see the AS30 and 100 when we receive those prefixes from R3. And again, well, it seems to be okay because R1 thinks that R3 is local AS30, so it thinks it has 2 hops to reach those prefixes, but in reality, again, there's only 1 hop. So if we're okay with that, we can leave it as such, or we can change it. We can change it and point R3 as, well, what they think it is, which is only AS30. How would we do that? So it's a simple fix. For the same neighbor, I'm gonna do this replace AS. If I add this command, obviously I should do the same for the switch 1, but switch 1 does not re-advertises those prefixes with any other path, so I can actually leave this the way it is. But for this now, so let's see this full configuration for that neighbor now. Do show run section router BGP. So I added this replace AS command here for that neighbor. Now what it changes, so if I go back to R1 and do the same thing, obviously we reset the neighbor relationship real quick, but now if I do the show IP BGP command and scroll down, all those prefixes originated by R3 now present themselves while received from R3 with 1 AS hop in the path, which is actually what it is in reality in my configuration. So that's basically final video in relation to local AS configuration. And obviously what happens next is at their convenience they can reconfigure their routers and point to AS100 and forget about the whole local AS at some point. But it's coming handy in situations where we migrate the router to a new AS and this router has a lot of customers or a lot of peerings that need to be reconfigured. So that concludes the local AS configuration.